Welcome students, and it's good to see you again today. We are going to be reviewing subatomic particles, which is atomic structure, or basically what is every atom made up of and how it affects itself. So here we go. This is the culmination of ions, isotopes, and atoms that we're working with. So to start with, we've got the symbol. To be honest, the first thing and the most important thing that I've got to tell you is for the symbol, you want to do this last. Okay, if the symbol is blank, do not bother touching the symbol until it's all said and done. Now, the atomic number is by definition equal to the protons. So as such, the protons is the same as the atomic number. So basically, these two columns are always going to be the same. So that's nice. Now, mass number is the two pieces that have mass, protons plus neutrons. So all you got to do is add them together and you're golden. Now, if you've got to get neutrons, you're going to take mass number and you're going to subtract out those protons. By doing that, you're going to get your neutrons. Now, something similar for electrons, your protons, you're just going to subtract out your charge, and that's going to get you electrons. Now, that's kind of harder to understand, so you're just going to have to trust me on this for now, because it's a lot easier when you understand the definition of charge is protons minus electrons. So taking that definition and restructuring it, charge is protons minus electrons. If you get it so that you want electrons alone, then the electrons goes to the other side, charge gets subtracted in, and you're left with electrons as protons minus charge. So like I said, trust me on this one because this is why that works. Now, type is all about that charge, okay? The charge is going to tell you what your type is. If your charge is positive, then you are totally dealing with what is called a cation. If your charge is negative, you are dealing with something called an anion. And if your charge is nothing, then you're just dealing with a simple old atom. Now, I like to remember this because plus kind of looks like a T. So plus cation with a T, and minus is kind of like that little subtraction in the A. So that's a way to think of it. Okay, now for the isotope, what it is going to be the element I dash mass number. So when you do this, I totally recommend that you just use the symbol as opposed to the element's name. But you could use the name if you want, but I think the symbol is just more useful and it's quicker. Now, if you have the symbol, if you need the symbol, remember it's going to be based on the protons. One of the most important features of atoms is that protons determine what it is. When you do your symbol, you have to remember that you have got your mass number in the upper left corner, your atomic number in the lower left corner, and your charge in the upper right corner. This is super important, so you're going to want to make sure that you do this each time. Okay? Now, if you have your symbol, then that's cool because your atomic number is listed. It's right there in the lower left. Same with mass number. It's right there in the upper left of your symbol. So if you've got your symbol, we're going to be putting what to do down here. Again, symbol means protons is just right there. Now, if you have your symbol, to get your neutrons, you're going to subtract downward. You're going to subtract downward like that, because that's going to be your mass number minus your protons, and that will give you your neutrons. See, mass number minus protons. Now, for your electrons, you've got your symbol here, and what you're going to do is you're going to subtract this way. You're going to subtract from the protons minus the charge. See, protons minus charge, just like what it says. And for the charge, well, that's easy. That's just up there. So if you have your symbol, it's pretty much easy street, and you don't have to worry too much about that. Now, I'm going to do some sample problems for you, and you're going to notice that it starts out with easy street, starting with the symbol all here. So the atomic number, I mean, it's already right there. It's just the 13 in the lower left, which also means that the protons are right there. Remember, these two columns are the same. Atomic number is protons, protons is atomic number. Now, mass number is listed right here as well. So you've got your mass number of 29, again, listed in the upper left. To get the neutrons, we're going to subtract down So 29 minus 13 is 16. We could also do over here, mass number minus protons equals neutrons. I mean, it's right there, what you need to do. For electrons, we're going to be, subtracting, the diagonal way. So that's 13 minus a positive 3 means my electrons are a 10. Now the charge is a 3 plus. Whether you write this as 3 plus or plus 3, I'm fine, but it's more professional to do 3 plus than plus 3. But either way, this is a cation. Now the isotope name here, you're going to do the symbol aluminum, and then you're going to just do your dash of 29. Say nice and easy, no problems whatsoever with that. Now when you do not have the symbol, it does get a little trickier. You want to do the symbol last, so we are going to totally avoid this spot here and just go right to our first blank. Our first blank is protons, and that's easy because it's the same as the atomic number. Neutrons is still mass number minus protons, so 41 minus 20 is going to be 21. Now for the electrons and charge, well, we need more info, and that more info is the fact that it's an atom. Since it's an atom, that means the charge is totally a 0. And if the charge is a 0, then that means the electrons and the protons are the same. So, I don't know, you may want to sit there and write that somewhere. If charge is 0 or if an atom, then this is going to equal protons. So I don't know if that's useful to you. If it is, cool beans, because it's true. Okay, at 20, our isotope here is going to be calcium, but it's not normal calcium. It's calcium 41, which is actually a little heavier than calcium normally is. So this is a heavy isotope, but we just do Ca-41. We then go back to our symbol. Now our symbol is going to be calcium because of our atomic number of 20, which we found out earlier. And we're going to write our mass number in the upper left, which is 41. And don't forget your charge of 0. But you don't have to do that. I mean, it's kind of better if you don't, but like sometimes we just get into the habit to do that. So I don't know. I'd prefer you don't do that, so don't. But if you do, fine. It's not the end of the world. It's just something that happens, something that you can choose to do or not. So we're going to now do our last one, which is our third example here. Now, our third example gives us protons, neutrons, electrons, and quite frankly, that's really all we need. Protons, neutrons, and electrons being, all three of the main pieces. So protons tells us that our atomic number is 39, same as the protons. Now, the mass number here is blank, and what we're going to do here is we're just going to add the protons and the neutrons together. So 39 plus 41, well, that's going to be 80, 80. We've got our protons, neutrons, electrons, so we're at charge. Protons of 39 minus electrons 37 gives us a charge of 2 positive, which makes this a cation as well. No anions in this example. Now at protons of 39, we have yttrium, which is Y on the periodic table, and we need to write down our mass number of 80. Back to our start. Finally, we can do our symbol of yttrium, which is 39. Our mass number is still 80. And our charge here is 2 positive. We now have all 3 parts. So there you go, class. That's how you do a subatomic particles question. It's a giant puzzle. Treat it like a puzzle, solve it like a puzzle, and it can be kind of fun. And it really does go over all the things you need for ions and isotopes and atoms. So take care, stay safe. I'll catch you later. Bye.